Hello again, geometry students. We are just about done. We've got two more videos left in this homeschooling time. Our second to last one is going to be on 10.6, which is slope and midpoint. So we're going to review slope, and then we're going to talk about finding the midpoint of a segment. So this connects back to what we did last class, where we talked about finding the length of a segment in the coordinate plane. We're going to continue to talk about things in the coordinate plane. So slope is an essential understanding value. You must know how to do slope in order to have any success next year in Algebra 2. Slope is going to be one of our core foundational ideas. So we're going to quickly review three different ways that people think about slope. And you can kind of pick which ways make the most sense to you to remember it. The first thing, a lot of you think of slope on a graph. And on a graph, a lot of you remember slope as rise over run, where you look at a line and you say, all right, it went up this much, over this much, so therefore the slope is however many squares you rise over how many squares you run. That's a great way to remember it, but that is only going to help us with graphing. Rise and run doesn't make a lot of sense unless we have a visual in front of us. So let's look at the other two methods that we're going to use regularly today. One of the key things to remember about slope is a rate of change. Slope describes how one thing changes relative to another. When you drive a car, you're thinking about slope, miles per hour, how your miles are changing for every hour you drive. That's a rate of change. That's what slope is. It's comparing how y changes relative to x. And in physical science, you should have seen this delta before. Delta y over delta x. How y is changing relative to how x is changing. This, to me, is the most important definition of slope because it gives you a base understanding of what slope is. It's relating how two different variables are changing relative to one another. All right, our final method is going to be here in our formula. y1 minus y2 over x1 minus. Subtracting is calculating the change. So these two are the exact same thing, but some of you are going to think more of it as a mental math. How are they changing? Some of you are going to think more over here with how is y changing by subtracting the y's relative to the x's changing using subtraction. Either one will work. You need to be comfortable with one of those methods. All right, let's look at a quick example of this before we talk about special cases. All right, so I'm going to do this problem in two different ways. And so that's why it says here at the top, you pick the method. Because I don't want to tell you you have to do it one way or another. I want you to decide which method works best for you. So to calculate the slope, we're not going to use rise over run because we don't have a picture. So if we don't have a picture, rise over run doesn't work very well. Let's see if I can get my marker to work here very well. All right, it doesn't appear to want to be working. So let's try this and that, and we still have nothing. All right, try one more time. All right, there we go. We got the marker to work. So on this side, I'm going to think of it as change in y over change in x. And I do that by simple mental math of, in my head, imagining from -3 to 7. Because remember, it's xy, xy. So from -3 to 7, how much did we change? How many squares did we pass? Well, that's got to be 10 squares because you went from -3 to 0, 7 more to get to 7. So that's a total of 10 squares on the grid paper. On bottom, our change in x went from 4 to 2. Now, this is critical. It went down. So therefore, it's going to be a negative change in x. It went from 4 to 2. That's down 2 squares, or down 2 spaces. So our slope would be 10 over -2. But we always have to reduce our fractions. And so 10 can divide by -2, giving us a slope of -5. Your slope will normally be a fraction, but in this case, because it reduces over 1, we can write it as a whole number, making our slope -5. All right, that's one way you can calculate slope, change in y over change in x. For those of you with good mental math skills, that's how a lot of you are going to want to look at it. But for those of you that like to say, I just want to plug it in the calculator and get an answer, you people are going to want to do y1 minus y2 over x1 minus x2. So if you're more of a calculator formula person, this is how you would do it. So we just put in little ones for the first one and little twos for the second one. And we say y1 minus y2 over x1 minus x2. Negative 3 minus 7 is negative 10. 4 minus 2 is 2. Negative 10 divided by 2 is negative 5. You see, either method gives us the same slope. We need to understand that slope is simply relating how one variable changes to another. And so however you get to the answer isn't a big deal to me. I want to make sure you understand how to do this. So either method works. Good luck. Let's now talk about midpoint. Whoops, looks like I misspoke. I almost forgot to talk about our special slopes. And so our two special slope situations here are a vertical line. When you look at the picture, it's a vertical line. And when you go to calculate your slope, you end up with a fraction that has a 0 on bottom. And as we all know, you can never have 0 on the bottom of a fraction. So we declare the slope there to be undefined, and we abbreviate with that with UND because you cannot have 0 on the bottom of a fraction. All right, our second special slope is this horizontal line. If you have a slope that doesn't rise at all, but it goes left and right, well, that's going to have a slope of 0 because it goes up 0 over 5 or over 7 or whatever the bottom of our fraction is. And so that is a slope of 0. So these are our two special cases. When you're doing your work, if 0 shows up on the bottom, then you have undefined. If 0 shows up on top, then your slope is 0. All right, now let's talk about midpoint. So we just reviewed slope, and now the second part of our homework is going to be to calculate the midpoint of a segment. So this goes very much with what we did yesterday, where you had to calculate the length of a segment. And you look at the picture here on the right, where it says how long is the segment that connects those two dots or connected the 2 points. That's what you did in our last homework assignment. Today now we're going to ask the question, what's the midpoint of that segment? Well, midpoint's a pretty simple idea. It's the middle point of a segment. Where does the exact center point fall? And to calculate that, we're going to use some common sense. Most of you have a base number sense to say, if you want to find the middle between two numbers, you find the average. So if you have the numbers 10 and 18, and you wanted to know what's exactly halfway in between them, well, you would just add them together and divide by 2. 10 plus 18 is 28, divided by 2 is 14. Halfway between 10 and 18 is 14. And that's exactly what the midpoint formula is. So let's take a look at that formula. Wow, just magically appeared. So the midpoint formula is exactly what we just talked about. If you want to find the middle of two things, you add them together and divide by 2. So to find the middle point of our segment, you simply add the x's together and divide by 2. That gives you the x value of your midpoint. To find the y values, you add the y's together and divide by 2. You find the middle. So when you look at the picture on the right, I went ahead and found the 2 points, 0, 5 and 5, negative 5. So in order to find the midpoint of this segment, I simply add the 2 points together, taking the x values, 0 plus 5, divided by 2. Comma, your y values, 5 plus negative 5 divided by 2. That point is going to be the midpoint of our segment. 0 plus 5 is 5. 5 divided by 2 is 2.5. 5 plus negative 5 is 0. Divided by 2 is 0. 2.5 comma 0 is the exact midpoint of that segment. And to double check that, the picture is really nice because I can just go over to my graph and go 2.5 comma 0. Yep, that falls on the line. And that looks pretty much like it's in the middle. So finding midpoint is going to be very simple. Add the x's together and divide by 2. That gives you the x value. Add the y's together and divide by 2. That gives you the y value. And now you have your second to last video done, reviewing slope and calculating the midpoint of a segment. Let me know if you have any questions. Good luck.